I was gonna do a video about time travel, the way physicists explain time travel, because I came up with a scenario that creates a paradigm. So I'm going to do a video about that anyway. But it brought me back to, I did a picture, it's back on my TikTok. You go back, I don't know, a few weeks ago, so it's probably back like 10, 11, 12 posts back, but somewhere in there in the top set of posts. And it's got a guy standing there. The guy represents a younger Albert Einstein, and on the backdrop is the universe, but overlaying the backdrop is a clock with a clock inside that, a clock inside that. There's actually another clock inside that, and it's relativity of time and space. But it's not exactly the proper title. That shouldn't have been the proper title for that. See, science, there's this big debate. It's been forever. And even today, there's still, you can find people like me who go to one side, and you can find people that go to the opposite side. I imagine Brian Greene is probably one of the people that go more the opposite side. But I think time is constant. There's some physicists, they try to argue that time is an illusion because there is no past and there is no future. We know there's a past. We can prove beyond all doubt that time exists because we can prove beyond all doubt that a past exists. For example, I've spent my life looking for Atlantis. That's what started my whole interest in science, which ironically wasn't even what I was questioning when I asked the teacher a question, and I was like, what the hell is Atlantis? And it's history and science and philosophy and everything around history that includes geology and physics and time and all this stuff. It opened up so many doors, and so it's why I'm always learning. I'm just continually learning. But time is constant. Geology proves that the past is real because we can look back in time through the rocks. And even easier than that, if it's clear out tonight, just walk outside and look up in the sky. If you can see one single star, you're looking back in time. You're looking back millions of years in time, looking at that star. So we know time is constant. But time is only constant relative to the space that we are part of, our observable space, our space of existence. For something much bigger and grander than us, time is still the same, but relative to them, their time is much slower than our time because of space-time. The time, space, and space-time are all different. They are actually three different things. Time is constant across all the universe. Time is constant. Unless we're in an infinite universe, then there might be an argument for that. We don't know if we're in an infinite universe or a finite universe. If we're in a finite universe, it's pretty much time is definitely constant. Space is definitely constant. But time-space is only constant based on the observer. I'm going to show you something here. I'm going to doing this as a quick drawing, so it's not a perfect circle, it's not a perfect cross, it's sloppy as hell. picture that as a clock. Over here we got 5 seconds, right? Let's just make an imaginary second hand and we'll point it at 2 seconds. As you get smaller and smaller and smaller, 2 seconds are still going by. 2 seconds are constant. Relative to the observer, inside each of these smaller circles, space is constant. But relative to us, as the outside observer, on a larger spectrum, space is getting smaller and smaller and smaller, but the 2 seconds are still always constant. So space is constant, time is constant, but space-time is only relative to the observer. And that's what my picture meant. But it brings up a conundrum. Because from the best way I can try to explain this is time and the speed of light are tied together. So for us, our perspective of what we can see as our universe is restricted by the speed of light. The universe is much larger than what we can observe, but the speed of light doesn't let us see beyond that because we will not live long enough to see beyond that as a individual or even possibly as a collective society. I mean, we can see further and further and further the longer we go on and on if we keep looking at that same one spot and, in a billion years, we're still looking through that same telescope, then we're going to see even further out than what we can now. But light restricts how much our perceivable universe is. But as you get smaller and smaller and smaller, that rule still applies. But the smaller you are, the smaller your observable universe is as well. And I've never actually got to sit down and talk with a physicist. If I actually did, I'd probably be able to get the answer to this or not. But I'm not sure Einstein's theory of relativity it's spot on. What I'm not sure about is if Einstein's theory of relativity fits that, and that's the way we look at it in science, or if it fits that, but that's not how we look at the theory of relativity through science. To some aspect, I'm sure we do, because GPS satelliting, that's what, it's similar to this. And they have to use that theory of relativity because they know when you're in space, time actually moves differently than when you're on the Earth. Again, you're part of a grander, much larger thing now, though. So you're on the outside of that second hand now. So, you're looking at that second hand from us, 1 second. But to someone who's way up here, and you have to extend that second hand way up there, that second hand, while we're looking up at it, goes like this, 1 second. And the smaller you are, that second hand goes 1 second. But it's still 1 second. Because for us, where we are in the medium, based on our being, relativity based on us as the observer, 1 second. So, I don't know if that's how science actually looks at relativity, though. Like I said, I've never actually talked to a physicist. I've spent my whole life studying science and history and geology. Yeah, I just learn. It's all I spent my whole life learning. I still learn. I'm still learning all the time. But I think that's the conundrum that makes general relativity and string theory bump heads. That's why they bump heads. I think it comes down to that right there. Because string theory I don't know enough about string theory, and I'm going to try to explain that, but I've learned enough about string theory to know that why, and I think that's why it bumps heads with general relativity. It comes down to size and the observer relative to size. But since we're talking about time, I'm going to bring it up. Time travel. Let's say we're going to go to a planet that's 4 light years away. And we can't do this, but in theory we can do this. But in reality we can't do it because there's too many obstacles. But in theory, there's a planet. It's 4 light years away. We create a spaceship that can travel 4 times the speed of light. That means it can get there in 1 year. 1 light year is how long it takes light to travel in a year. So that's a light year. It's just easier to measure because space is so expansive. It's just easier to measure it that way. So you get this guy, he's on this spaceship, and he travels to this planet that's 4 light years away, and he gets there in a year because he's traveling at 4 times the speed of light. But we have an observer here on Earth whose job is to just 24 hours a day, 365 days a year, just non-stop watch our astronaut. Because we can only observe the astronaut at the speed of light, it creates this conundrum because the astronaut is there on the planet. Let's say he spends 3 months exploring the planet. Spends 3 months exploring the planet. And then he comes back at the same speed, 4 times the speed of light. So he's been gone 2 years and 3 months. To our observer, he's only just finishing up if he can actually see our astronaut. You know, theoretically, this is all theory, but let's just say that we have this telescope that's so powerful that he can see our astronaut on this planet. Our astronaut is still on the planet, but he's here on Earth. But to the observer, he's still on the planet because of the speed of light. What happens if our observer is watching this and we just have the astronaut walk in, say hello, and the observer looks over and says, hey, you're back, good to see you. And he walks out and he goes back to watching this. And now he's watching our astronaut come back. And let's make it even more interesting. Let's say it's all televised around the world. But everybody around the world saw our astronaut come back. They saw our astronaut on TV waving to everybody. Yeah, it was a great trip. You know, and we're already 3 months into studying everything he brought back. But now, live on television, we're again, because we've been observing it with these cameras this whole time, we're now watching the ship land again and the astronaut come out again. The day he landed, it was a nice, bright, sunny day like today. The day the ship is landing now, it's a rainstorm, or maybe it's a snowstorm. You know, a freak blizzard came in, and it's just horrible weather. There's snow lightning, you know, just this. But, so we know we're seeing two very different things. But, what happens? I know what I'm supposed to think happens, but that doesn't make sense. And I know what science tells me will happen, but that doesn't make sense. Because in the observer's mind, this is happening. And like I said, if it's televised, you have people from all over the world watching this happen. And you're going to watch him on the television walk across the tarmac and into the building, and you're going to have cameras in the building that are watching him. It's just this paradigm created by the physics of light. He's not real. The real one came back months ago. Actually, the real one, let's see. You're looking at 4 years and 4 years, so that's actually 8 years. And then so it's eight and a half years have gone by that we've been watching him based on the speed of light, but he was only gone 2 years and 3 months. But he's been gone, but we've been watching him for 8 years and 3 months. There's a 6-year difference between reality and this optic. But the optic is reality also, because light is real. It's kind of where, this is where they come up, you know, when you think like that, that's where you can come up with this whole idea that we live in an illusion. Because based on physics, this will happen. If you travel 4 times the speed of light, that is what will happen. But the second coming, it's an illusion. It's real, but it's not real. And that's kind of where they come up with this idea that the world we live in is an illusion. That's where physicists come up with that idea. That's how you come up with that idea. Because you can make a scientific theory that's completely rock solid, based on everything we know about light, the speed of light, So you can make this theoretical, where we have the math to prove that theoretically, yes, you can travel 4 times the speed of light. As a matter of fact, we've always been told that light is the fastest thing in the universe, but it's not. There's actually 2 things. I can't remember what the other one was. There's something else. There is something that moves faster than the speed of light, and science has found that. They've actually got proof of that. But there's also something that we've never observed that is faster than the speed of light. The expansion of the universe. If the universe is still expanding. If the universe is finite, then the universe might not be expanding anymore. It might just be that we find these gravitational ripples, and because they find these gravitational ripples, they don't understand why we can't find the gravitational ripple from the Big Bang. We can't find none of that. If the universe is finite, then the universe might already be done stretching, and because it's already done stretching, the final ripple Because you know how the ripples, you get there's only a finite number of ripples before the water smooths out smooth as glass again. That final ripple is approaching the end of the universe. And it's that final ripple that's pulling everything, and that's what's making the universe stretch. And it's nearing the end, and that's what's making it appear that the universe is speeding up in the stretching. That's a really scary thought. I really want to believe the universe is infinite. But if the universe is infinite, then the universe is an illusion. Maybe not for us. Maybe for us the universe is real. But it's just as likely that the universe is an illusion. It's also just as likely, if the universe is infinite, it's just as likely that everything, you, my dog, everything around me, all the birds, all the insects, the clouds, when I die, gone. None of it exists. If we live in an infinite universe, that actually is possible. That's just as possible as anything you can conjure up in your mind in an infinite universe, it is possible. Dragons are real in an infinite universe. Vampires are real in an infinite universe. Hillary Clinton was president in an infinite universe. Hitler won in an infinite universe. And then things you can't even start to wrap your mind around are real in an infinite universe. I mean, in an infinite universe, I could look out at the sky and I could just see, because I could look up at the night sky and I could look up and you can see the Milky Way, and I can see all these holes in it because of all these black holes that are just all, and I can watch these black holes all go and merge. And I mean, anything you can even start to dream up. I'm watching Marilyn Monroe on a dragon being chased by John F. Kennedy saying, "I love you," and Adolf Hitler saying, "Oh, please forgive me, please forgive me, please." You know, like I said, anything you can, all of it going on at the same time in front of me. In an infinite universe, that is a definite reality. In an infinite universe, Jimmy Hoffa was president. In an infinite universe, the mob never existed. In an infinite universe, Earth never existed. So an infinite universe is just... But I'd rather, there's something about that that's just much more reassuring than a finite universe. A lot of people like to say, look at our world. Our world is proof of intelligent design. Even scientists are now starting to say our world and our physics are proof of intelligent design. So you have the theological, it's proof of intelligent design by God, and scientific, it's proof of intelligent design by something. I believe there's a God. I take more of the Benjamin Franklin view that, God put everything in motion and he let it go, kind of like spinning a top. And he just let it go. I think from time to time, God may have even intervened. I don't know. But existence isn't proof of intelligent design. And we have proof of this. So both the scientists who think we live in a matrix and the theologians who think this is proof that God designed it all, there's proof that they're both wrong. Our sun. Our sun is proof that they're both wrong. You know why our sun is proof that they're both wrong? We have a orange dwarf, or is it orange? Yeah, orange dwarf. It's not a particularly stable star, but it's an okay star. You know, it's going to last a couple billion years, which is kind of interesting because there's a lot of things going on with all the volcanoes coming back to. I'm not going to get into all that right now. That's a whole nother about what's coming to the world for that with the pending ice age that can't be stopped because of all the volcanoes coming back to life. But the sun itself isn't particularly stable. It's not the best sun for life. I mean, we've gotten really lucky. But if this was all designed by some greater knowing power, our sun would be a yellow dwarf. Because where our sun lasts billions of years, a yellow dwarf lasts tens of billions of years. And where our sun is really, while not radically unstable, it's still unstable. A yellow dwarf is barely unstable. The yellow dwarf is as stable as you can get. You cannot get a star more stable than a yellow dwarf. If this was all by intelligent design, our sun would be a yellow dwarf. The most stable of all the stars would be our sun. If we lived in the Matrix, a yellow dwarf would be our sun. If we lived in a computer simulation, in almost every single instance that you can dream of, our sun would be a yellow dwarf, not an orange. It'd be the more stable. There is one instance where you can say, okay, if we're a simulation, why would they give us a more unstable sun? Maybe they've been going through the suns, and so the last few suns were just complete disasters, and now they're like, oh look, this sun is working. And if we're in a simulation like that, then the next simulation is going to be divine, because we'll have the yellow dwarf. But that's the only instance where they would have our sun. If this was a simulation, our sun would be an orange dwarf and not a yellow. It's the only, I don't know, maybe I can't get into the shoes of an alien. Maybe there's something that, I just can't think of. But I mean, realistically, there's no other reason. That would be the only, and almost in pretty much every other reason I can come up with, we'd have a yellow dwarf. Same with God. He would have gave us a yellow dwarf. Like I said, I believe there's a God. I don't know what God is. I'm not a heretic. I don't tell people this is the only thing, and this is the only possibility God can be. That's heretics. I'm not a heretic. I don't know whose religion is right. I don't know whose religion is wrong. I think religion is really good for people. I mean, somebody told me years ago, and I've come to learn this, and I've come to realize it's the absolute truth. People need faith. The problem is, through their faith, religion, what they said was, religion made man civil, man made religion uncivilized. That's the world we live in today when it comes to religion. And they're absolutely right. But even with all that, I still think people need faith. No matter what it is, whether it's you believe in a God, you're an atheist, it doesn't matter. You need to have faith in something. If you have faith in science, if you have faith in math, you have faith in the bird that, just landed in your front yard, whatever. You need to have faith in something. Because without faith, there's just no moral guidance. So, we need faith. I think there's a God. I just don't know what God is. I'm not an atheist. Like I said, I'm actually I'm a deist. That's, I believe there's a God. I just don't know what God is. For all I know, we have, if what the government is telling us is true, and we have bodies of aliens, for all I know, one of them aliens are the ancestors of our God. I don't know. I don't know what God is, but I think there's a God. And if God put everything in motion, it's clear he put certain rules in motion, and this is one of the eternal rules. Relativity is one of the eternal rules. Time is constant, space is constant, but space-time is a constant based on the perceivable perception of the observer. Space-time isn't constant. The smaller you are, the faster space-time seems to go by to us. Larger than us, space-time seems to go by slower based on the observation of us. But it's all at the same time. It's still always 1 second, 2 seconds, 3 seconds, 4 hours, 10 days, 3 years. It's still the actual flow of time is constant. And our relative space is always constant. Space-time is neither space or time, and that's why it fluctuates based on relativity. So if we could look at a clock the size of an atom, even though it's only moving 1 second per our second, it's going to look like it's moving much faster because it's so small. And so our perception is just going to look like it's going faster. And in our minds, it just makes it's like our minds play tricks on us. go and you listen to a really boring lecture, or you watch a really boring movie, and it's only an hour and 10 minutes long. But by the time it's over, you feel like you've just been there forever, and you just wasted so much of your life. And you're like, oh my God, thank God this is over. And you get up and you're just all worn out. You feel like you've been sitting for days. You feel like you haven't moved in forever. You're just all tight and you're all crunched up, and you're trying to walk it all off and get stretched out. But then you go to a lecture that you find really exciting, and you just really, it's mind-blowing to you. And you just, the whole time you've just been excited, and you've been adrenalized, and you've been just focused. Or a movie, really awesome movie. Maybe it's a really awesome, guys, really awesome action-packed, explosions, car chases, gunfights, Ronin. I love Ronin. It's one of my all-time favorite movies. Or Enemy of the State, those T2. When those movies ended, they, 2 hours, hour and 45 minutes, 2 hours and 20 minutes. I really like the Lord of the Rings movies, really long movies. But when they were over, I felt like, wow, it's over already. And I had a spring in my step, I had no body aches. I didn't feel like, I felt like I just walked in. Relativity. It's an amazing thing. But as an observer, the same thing happens. When you're observing something so small, to us, it's beep, 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 beep. It's just all over the place. But if that atom is actually a complete universe, and inside that universe there's worlds and planets and stars and suns, and they're just so small that we can't see them, and on one of those planets there's life like us, and it's observing. And the time that this thing went bing, 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 and then evaporated, 2 or 3 seconds. For the people on the planet that can think intellectually like us, they had billions of years of history behind that, like us, they look at, and then there was billions of years of future that went by. So billions and billions and maybe trillions of years have gone by for that little tiny planet inside that atom, because that atom, it encapsulates a whole universe. But for us, it was 3 seconds, and then it was gone. That's relativity. The difference is, inside them, while that 1 second went by, inside that 1 second, they have quadrillions of seconds. But it was still 1 second. 3 seconds. So time is a constant, but space-time stretches and shrinks according to the observer. Because like I said, we watched that atom. You time it on your clock, that atom went around 3 seconds. Bing, 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 and then gone. But only 3 seconds went by. 3 seconds went by, and that atom was there for 3 seconds. So time is constant. So it's just really... it's just mind-blowing. I mean, I still have a hard time wrapping my head around it. And there's something about that idea now. There's something about that. It keeps tickling, and I can't put... I keep... it's right there. And I get it. But... it's that understanding that when we figure it out, that's how we're going to travel around the universe, and we're going to visit other galaxies, because time is constant, space is constant, but space-time is malleable. And when we figure it out, and we figure out how space-time is malleable and how we can manipulate that malleability to our advantage, we're going to be able to map out the whole Milky Way in a year, 2 years. And the really weird thing about that, though, is, like I said, if you go back to the astronaut, to everybody, if they go out for 2 years, they map the whole Milky Way, and they come back, they did this all in 2 years. 2 years goes by. But if we have something observing this all happening at the speed of light that it travels, the weird thing is the observer, even if it's a video camera, but the observer will never see them come back to the planet. It's really weird. Especially if the observer is a video camera. If it's fixed on just following them around, it can only keep up with them at the speed of light. And if they're traveling faster than the speed of light, because we figured out how to manipulate the malleability of space-time, they're gone 2 years. We go to, what is it, Proxima B? There and back in 6 months. 3 months. Who knows, maybe. It might be, like flying from Houston to Atlanta, going to the moon now. Going to Mars. It'd be like, just a regular 8-hour flight, because we figured out how to manipulate the malleability of space and time. Of space-time. We can't manipulate space, and we can't manipulate time. But we should be able to manipulate space-time. And it's not time travel in the sense of H.G. Wells, but it is time travel in the sense of Einstein. It's somehow, I have a feeling it's possible, if I don't see it happen in my lifetime, I'm going to see it figured out in my lifetime. Somebody's going to figure out how to do it. And then we just need to build the technology to do it. And one, if I had to guess, it'd go back to, if the government is telling us the truth and aliens are real, and I can't see why the government would lie about that all of a sudden. They've been lying all these years that they weren't real. But if aliens are real, I have a feeling that their technology is all light-based. And they've somehow figured out how to harness light. And because they can harness light, they can actually move faster than light. And like I said, we know for sure. One thing we are certain of, well, it's a 50-50 toss. Is the universe finite? And maybe it's not so. If the universe is infinite, then that means the universe is still growing, and that means the expansion of the universe is faster than light. So there is something out there faster than light. The universe cannot expand if it's not expanding ahead of light. I mean, it's fundamentally, it's not possible. Light can't go where there's nothing. Which means something has to be ahead of light. And that's the expansion of the universe. It could be other things, but the one thing that would definitely be ahead of light is the expansion of the universe. It's the one definite thing that if the universe is still expanding, it's expanding faster than the speed of light. That is a definite. Might not be much faster than the speed of light, but it's faster than the speed of light. And then again, it could be a lot faster than the speed of light, but it's faster than the speed of light. It's a definite. That is a definite. And so, I like to tell people all the time, when we're talking about alien technology, and they say, it's just so much more advanced. It's not more advanced. It's just, it's completely different. To the aliens, all our technology might be, they probably look at our technology as mind-blowingly advanced. They might not understand how an ICE engine works. Internal combustion engine. An ICE. They might not understand how that works. They might not understand how our rockets and spaceships work. They might be just as befuddled by our technology as we are by theirs. Because they're just completely different. Our technology is all born out of fire. That is the one thing. That's something that people don't give that much thought to, the evolution of technology on our planet. Our technology is born out of fire. If you come from a planet where there is no fire, your technology is born out of something completely different. So it's a completely different technology, and it might, you can even argue that, they're both following the same evolutionary track, Even though they're completely different evolutionary paths, they're still taking these same leaps, these same evolutionary leaps. It might be side by side, steam engine and photon engine, side by side. Taking these same leaps side by side. They're just completely different technologies because they come from completely different beginnings. Like I said, all of our technology is born out of fire. If they're from a planet, aliens are from a planet that there's no fire, their technology is born out of something completely different. They don't understand how to use fossil fuels because their technology isn't born out of fire. There is no technology that embraces fire. So how would they understand that oil burns? How would they understand that you build this little mud sarcophagi, you stuff it with wood, you keep blowing air on it while it's burning, and inside you have this pot with this metal that you got out of the dirt, and it melts down, and then you pour it into this mold, and now you got a knife. But to them, they figured out how you take these crystals and you combine these crystals with these crystals with these crystals, and it reflects the sunlight through there, and out of a rock made of metal, you cut out your knife. The technology born out of something completely different. It's not advanced. It's just different. And on the time scales of things, their technology can be thousands of years behind our technology when it comes to the developmental stage of where they are with their technology. We got 300,000 years behind us, 400,000 years behind us. They might have 100,000 years behind them. So on that, basically our technology is the more advanced technology. It's just the technology. The idea that aliens are real. I've always been, I've always been open-minded, but it doesn't mean that I accepted that aliens have been visiting us recently. I've actually to some extent accepted that aliens probably visited us in the past. But that, Ronald Reagan might have met King Zulan from the planet Alzazir. Come on. Come on, man. Really?